This is the Nexo I rocket at its current state of development, and it is the first liquid-fueled biprop rocket of Copenhagen Suborbitals, and only the second one ever attempted in Denmark. It should be considered, shall we say, the light version of the Nexo I class series of rockets that we're going to do here at Copenhagen Suborbitals. It's going to be using the blowdown operating mode, meaning that we're going to top up the tank pressures with helium, and then allow the tanks to deplete with the helium expanding directly in the tanks. So the DPR system will not be available on Nexo I, it will only be on Nexo II and forward. And this means, of course, that Nexo I won't get to the same level of altitudes as Nexo II will, but in essence the altitude is insignificant in terms of Nexo I, as this is more a, shall we say, a technical test of the different systems that one has to master to do biprop rocket systems. So we will be looking much more for the performance of the individual subcomponents in the rocket and the overall design as such to weed out any, shall we say, misdemeanors or non-conformities in the design and optimize that towards Nexo II. Also, one should always keep in mind that Nexo I and Nexo II are part of the roadmap towards the Copenhagen Suborbitals Speaker rocket. And the Speaker rocket will be the full-scale manned vehicle. In that sense, Nexo I and II aim to demonstrate and familiarize all the people here at Copenhagen Suborbitals with the technologies required to develop and fly a Speaker class rocket, which is a much larger vehicle than this, of course. But the advantage of this step, or intermediate step, is that all the techniques applied, they double to the Speaker class rockets. So what we develop and test on Nexo is the stepping stone required to do Speaker in the coming years.
Now, compared to its predecessor Sapphire, Nexo I is about the same length. It is 30 centimeter diameter, where Sapphire was 22. It is slightly heavier. It is not a much bigger rocket. We also don't expect it to fly faster or higher. So the change is all under the hood. Importantly, Nexo I flies our first bi-liquid engine. And we're switching to bi-liquid, though this is a major technology step, because bi-liquid has shown to be more scalable. So if we can make bi-liquid work and fly in this size, we have a design that can be scaled to a bigger rocket, whereas the hybrid motors are notoriously difficult to scale to bigger size.
My name is Thomas, and I am supposedly the project lead on the Nexo I rocket. Now, fortunately, the crew working on the Nexo I rocket they are so self-propelled that my job has been very easy. So my major contributions has more or less been calculations and the initial overall design, and then purchasing stuff for the Nexo I rocket. I'm not myself a metal worker, so I've not been working on it myself, and fortunately the crew is very dedicated and working very hard on it.
Hello, my name is Jacob Larsen. I've been doing particularly two things with this Nexo I rocket and the launch. The first of all is that I've been putting together several of the BPM-5 engines we're using to propel the Nexo I rockets. trying to learn how to best build them and how to improve the building as I went from one prototype to another. The second thing is that I'm a co-designer on the Nexo I rocket, the mechanical airframe from the avionics section and all the way down to the exhaust nozzle. What I'm particularly fond of already is this entirely new design procedure we've been using for the Nexo I rockets, which is basically a modular, compartmentalized set of sections which you can bolt together and pull apart as you wish.
I'm Jonas Bjarnø, and I'm the technical advisor on the Nexo I project. And I've had the pleasure of doing the initial dimensioning and trajectory and performance calculations for the Nexo I.
My name is Flemming Nybo. I work with guidance, navigation and control, which are the fancy terms for trying to make the rocket fly straight up. So, as you may know, we have had a jet vane that has survived a static test successfully several times. So we now know that Nexo I can be steered by jet vanes like its predecessor Sapphire. So as such, the navigation and control system architecture will be identical to Sapphire, and the core of the control system can actually be reused. There are also some changes. Besides the new jet vanes, the control system must be adapted to the physical parameters of a different rocket. That is, its mass, its inertial moments, and importantly how these numbers progress as it uses its fuel during the burn. Also, the system must be tuned for the specific aerodynamics of the rocket, and the aerodynamics of Nexo I have been modeled by Jonas Bjarnø, and the parameters from this work will be added into the control system. Also, we are flying with an analog devices eye sensor IMU. Sapphire also did that and flew with what I believe was the best MEMS IMU available for the purpose at the time. But since the product line has progressed since then, we now have the luxury of a slightly better performing eye sensor IMU. So we expect to get a little tighter navigation performance without any extra effort on our side.
My name is Jesper, and I made this avionics section for the rocket, Nexo rocket. This is the part of the rocket where all the electronics and control equipment are placed. The GPS, the radio, and all communication for the rocket.
Hello, my name is Christian, and I'm the chairman of Copenhagen Suborbitals. For the Nexo project, I have mostly been a coordinator. I've been leading our weekly meetings, and my main contribution is to make everybody work together, figure out who is in need of extra help or extra resources, and have a look at the economy, making sure that the money will be well spent and that we will be spending the last kroner at the last day of the project.
Hiya, my name is Lily, and I mainly work on the turning lathe as far as the production is concerned. And for the Nexo I rocket, I've been working on the production of the dome and the alloy for rolls, which is what you weld on the tanks in order to be able to fit both the stainless steel and the aluminum together. And right now I'm working on the flange for the Nexo II rocket. So that's what I'm doing at the minute.
My name is Martin, and I have been designing a small contraption that links the electrical motor that controls the valve with the main valves for either locks or fuel.
My name is Bo Brandstrup. I am responsible for the wiring and cable harness in the Nexo rockets. The cable harness is going from the avionics bay at the top of the tanks, traveling in our cable channel all the way down to the engine compartment of the rocket, where it connects the avionics to the engine controller and the rudder servos. I'm also responsible for the cable harness inside the avionics bay, which connects the different modules of the rocket, batteries and the power supply and our guidance computer and our radio. On top of that, I also have assembled the CS Arduino boards and defined all the cabling inside the boxes for the modules.
Hello, my name is Stefan Eisenknappel. I am an intern here at Copenhagen Suborbitals, and I help the guys wherever they need me. And actually right now I am working on the baffles, bending the baffles for the rocket. It's like the shell, and looking if all the holes are lined up, and helping the guys with assembling. Also I am doing welding, so I was turning some fittings on the lathe, which goes to the LOX tank, and I'm also welding custom-made fittings, so I just weld them together. And well, that's what I'm doing, and I'm happy to be here.
My name is Rune Hensel. I have been doing the design of the nose cone, which is actually what we can see right here, in the process of being made. And then I have been doing all the LOX certification and cleaning of LOX parts that are in contact with LOX.
Hi, my name is Morten. I'm a member of the board in Copenhagen Suborbitals. And on the Nexo project, I have been doing what I usually do in Copenhagen Suborbitals. That means I have been running the logistics and the purchasing department, making sure that we get all we need at the right moment. I have been ordering the tanks for the rocket from a subcontractor and making sure that they actually delivered what we were supposed to get.
I'm Peter Mortensen. I am building a video transmitter for Copenhagen Suborbital that's going to fly on the Nexo rocket. The project was started by Alex, and I'm finishing the transmitter part, so we can try to transmit DVB-T down from the rocket down to the platform.
My name is Peter Meinke. I have made the most of the welding in the Nexo rocket, the pipelines. In the test stand I have developed the mount for the tanks, the LOX tank, and the most of the welding of the setup for the test jet vane. Also the jet vanes mount for the Nexo rocket. That is the design of the rocket and the design of the test stand also been involved with.
Hi, my name is Flemming Rasmussen. I am a software engineer of profession. So that's the reason here in Copenhagen Suborbitals I mainly do mechanical design and manufacturing. I have the lucky position that I work in a company where I have access to 3-axis CNC milling, and thus a lot of tasks concerning that is coming my way. As an example, for the Nexø, I have manufactured and partly also developed a lot of the parts concerning the thrust vector system. Here we have the graphite jet vanes. Here we have the vane bearings, which I've all milled out, and together they form this beautiful piece of equipment that hopefully will point the Nexo rocket towards the skies. Unfortunately, on this project, I have not had too much time because my other job takes up a lot. So basically that's what I've been doing. But hopefully, I'll be back for the speaker with more inputs.
My name is Peter Scott. I'm involved with a number of different parts of the rocket. First, I've written the software for the engine controller that we use to control the engine and all the sensors and servos around it. Secondly, I've designed the telemetry radio system, which we use for getting telemetry from the rocket and down to Earth, and also getting commands from Earth up to the rocket while it's flying. Third, I'm involved in the data transmission system for our video live stream system, that is getting the video data from the ships and all the way back to shore and onto our mixing system. And last, I'm involved in doing maintenance on Vostok, our command ship.
Well, welcome to the OB1 here at Copenhagen Suborbitals. This is where we are actually mixing the live stream. My name is Peter Marsk Møller, and I have been helping creating this system we have here. We have a couple of screens. We have a mosaic screen that we usually also send out into the live stream, and we have a premix and a postmix. The premix and the mosaic is taking place, being mixed in the Baltic Sea, and we control it here from Copenhagen. The postmix, where we add text and commentators, audio, we mix here in Copenhagen, and then we send it to YouTube Live. We have created a little system where we can control the mixers in the Baltic Sea, in the middle of the Baltic Sea, and we control both the audio and video. And that's about it. Usually we are a couple of people sitting here. We have 1 or 2 commentators, and then we have 1 or 2 taking care of all the technical streams. That's about it. I hope you enjoy our streams.
My name is Niels Foldager, and regarding the Nexø rocket, I have been involved in the engine group that designed the engine. I have dealt with the evaluation of the injector design, and regarding construction, I have dealt mostly with the airframe, where I have made a lot of milling and drilling, making threads, and being on this lathe here.
The Nexø design is the first rocket design of the history of Copenhagen Suborbitals that has been drawn in detail before building commenced. Thomas Madsen did the drawing and detailed mechanical and metal design work using the SolidWorks software. Thomas Madsen was also a part of the team that designed the BPM-5 rocket engine and its one-piece CNC melted injector. After finishing the design work, Thomas Madsen has taken part in the manufacturing, assembling and final adjustment of the Nexo I rocket.
Nexø I kan sagtens stå her.
Jørgen Skødt has welded part of the Nexo I piping system, and furthermore he is part of the visual design team and in charge of production of labels and stickers for Nexo I. Christian Ravn did part of the Nexø I rocket design, especially calculations. He also performed reviews on the other parts of the design. Christian Ravn designed and manufactured the burst disc system that serves as a secondary safety mechanism guarding against tank rupture due to unintended overpressure.
When you look at Nexø I, you see a lot of threads and a lot of screws, but not so much welding. And the purpose of this is that the engine, the rocket, is easier to assemble. Things can be bolted on and taken back off and fitted back on again during the process. And this is also more serviceable should something happen to the rocket that needs to be repaired. We have also had a different design process this time. Everything has been drawn in CAD beforehand, so we have known upfront how we would fit all connectors and pipes and wires so that nothing got in each other's way. And as such, this has been a good structured process, and also a process where it was easier to involve many people in a team effort because everything was planned ahead.
The other thing I'm looking very much forward to is seeing this seemingly a very small engine propel this very large Nexø rocket high up in the sky. It looks, the engine looks small in the airframe when you're looking at it, but it's still good for more than half a ton of thrust. So it will definitely get off the rail. I'm just waiting to see how high.
The end of the roadmap for Copenhagen Suborbitals will be the Speaker rocket. And the Speaker rocket is our manned launch vehicle designed to carry a passenger vehicle of approximately 300 kilograms to an altitude of 100 kilometers or slightly above, so as to reach the common line and bring back the passenger alive. It's a substantial rocket from an amateur perspective, and the technologies required to do that are those that we aim to demonstrate with the Nexø rocket series. And this is actually why we do the Nexø rockets as a stepping stone towards realizing Speaker. We need to demonstrate the ability to run biprop systems, all the control, the DPR system, the pressurization systems, the avionics involved, the recovery systems, and all those subsystems need to be realized from scratch because it's not technologies that were previously available in Copenhagen Suborbitals. And the Nexø rocket series will allow us to do that. The Nexø I rocket will be the first step down that path and will allow us to evaluate a biprop rocket system and in particular the startup sequences of the engine at sea, the operations associated with tanking and detanking and working with biprop systems in the rough environment that a sea launch does involve. And it'll allow us to work for the first time also with composite structures and more lightweight designs than we have previously worked with in Copenhagen Suborbitals. So the Nexø series should be considered a vital stepping stone towards the future of Copenhagen Suborbitals, the Speaker rocket series.